In this video, we're going to talk about how to approach problems like we saw in discussion section this week. So this will not be a solution video, but it will be a solution strategy video. And so what we're going to talk about is how to begin to make sense of what we're asking you to do when asking you to solve problems like discussion section. So the first thing that I'm going to notice is that the goal of the problem is I'm asking you to execute a new instruction, such as JAL, jump and link, target. So target is where the place I want to jump to. So we're told that it's a J type, which means it's going to take the format of opcode and then address. So target is your address. This is the target that you want to go to. Or we're going to calculate that. And so what this tells us, so that tells us what everything is. So the opcode tells us that we're doing a jump and link, and address is where we want to go to. So the really important part in this question is here I have two what we call register transfer instructions that tell me how I'm going to implement my jump and link instruction. So basically we have to do two things at the same time on the architecture. One is get the value of PC plus 4 into register 31, and we need to somehow create this guy and store it into the value of PC. So let's take the second one first. This is number 2. Let's do number 2 first, and then we'll look at number 1 and just think about what information do you need to know. And so this is a bit weird. And so we got to everything that we look at on our MIPS screen sheet uses a bus concatenation notation, whereas this is using bitwise Boolean expressions. So you've got PC and F00. So what is this? So let's look at this first segment, PC and F. So what is the output of this Boolean expression? Well, you're going to have your PC value, which is a 32-bit value, and you're ANDing it with F000000, which will be 1111 0000000. So basically, this guy is going to be chopping off everything. So it's going to save the top 4 bits, the 31 down to 28 of the PC, and ignoring the rest. These are all going to be zeros now of the PC. Then this guy is saying take the target value, which is your address, and left shift it by 2. So what we should see is target, which is the opcode is bit 31 down to 26. So this is bits 25 down to 0. So, and then what we're doing is left shifting by 2. So we're basically going to have some value address for a few bits. And then we are going to append 2 zeros at the end of it to make it a left shift. Some of this, ideally, this should be starting to look familiar to you, and I'll let you figure out where do we get this. But I can tell you, this whole expression, PC and bitwise ANDed with F000000, or with the left shifted target, is actually already somewhere in your architecture, and it's already actually being sent to PC. So here you want to be focusing down here somewhere, trying to figure out where is that expression, right? Where have I already built that functionality? Okay, so that's what you're going to try to do, and then you're going to need to consider control signals. So you're going to use this guy, your control type, to figure out, okay, what value should I use to make this happen? Because ultimately, what I'm going to be doing is storing this into PC. PC's over here. So that's why I need to know what control type I'm going to do. So that's part 1. Okay. Or part 2. Now part 1 is a little trickier. Here we need to find the value PC plus 4 and put it into register 31. So the first question you should be able to ask yourself is, where is PC plus 4? Is it here, here, or here? That's the most important question that we need to figure out. And once you figure that out, you want to put that into the data of register 31. So this is saying, hey, put this into that R of 31 is telling you you're putting it into the data of R31. So R of 31 is somewhere in the register file. How do I put information into the data of a register? And then how do I specify that I want to get into register 31? What signal do I need to set on the register file to get to register 31? So those are the things you need to be able to pay attention to. That's how you need to be able to parse it. So as a quick recap, what you need to be able to do is look at these instructions here up at the top. Those are the most important parts of the problem. They tell you everything you need to do to execute the instruction that we're trying to execute. And then you're just going to set control signals and maybe make some modifications to the hardware, such as, I'm going to give you a hint, you're going to need to change the multiplexers over here to make everything work. So what I would recommend then, the last part, is once you figure out, okay, I'm playing around up here, I'm playing around up here, is I would trace where all those signals are going. And then, so I can tell which signals actually matter and which ones are going to get zeroed out. So, for example, once I figured out whatever this nasty expression in part 2 is, I need to figure out, okay, how do I get that? So I'm going to have PC ended with F0000. So I've got my PC value coming out here somewhere. So do I go through this ALU? Or do I go down here? Which one is it? And start highlighting the route that you want to take. And then you'll be able to see what each of the multiplexers are going to need. You'll be able to tell what you like, signal like write enable, read source, and make sure you fill in as many of these values as you can. That's it.